In this video, we are going to set up a triple integral over a tetrahedron. All right, so here we are integrating just volume, and so that just means that we are integrating 1 and dz, dy, dx. So now we have to figure out the limits. So tetrahedron is bounded by the coordinate planes x equals 0, y equals 0, z equals 0, and also a plane that is given, the actual equation of the plane is given. So 9x plus 10y plus 12z equals 180. So what you need to understand is what is this going to look like. So if you set y and z equal to 0, you will then get 9x equals 180, which is going to be the intersection of this plane with the xy plane. And so that just gives you x equals 20. So it's going to intersect x-axis, which obviously I'm not going to draw to scale, at 20 right here. Now, if you set x and z equals 0, then you will get 10y equals 180, which means that y equals 18. So that's when this tetrahedron, again, not to scale, is going to intersect the y-axis. And then for the z, you set x and y equals 0, and you will get 12z equals 180. So dividing both sides by 12 will give me 180 over 12, 15. Okay, so that z equals 15 is where it's going to intersect over here. So if you think about what this looks like, this is going to be like a slanted triangle bounded by that slanted triangle and the xy, which is the bottom, xz, yz planes. That's your tetrahedron. Okay. The first thing you do, and it is going to be really easy to set up once you know what to do, is you're going to look at the values of x. So x are the extreme values, right? Like, so this is your triangle right here. Because remember that these two limits are the limits over the projection onto the xy plane. And the projection is the yellow rectangle. So the outside is just going to be 0 to 20, right? What about the middle? Well, this triangle, like if I just draw the actual triangle, so this is, again, not to scale 20, and then this is 18, and there's your line, and the region that we are integrating over is this right here. The bottom curve is just going to be y equals 0, right? So it's clear that that's going to be y equals 0. And then the top curve is going to be that slanted line, which has a negative slope of 18 over 20, and the y-intercept of 18. So if you knew this, you could, actually 18 over 20 is 9/10 x, you can come up with it. There's another way you can do this, because this line also belongs to that whole triangle, right? Which is the tetrahedron. So if you were to set z equals 0, you will then get, so if you just imagine that this is not there, you would get 9x plus 10y equals 180. If you solve that for y, you would get 10y equals 180 minus 9x. And then divide by 10, you get 18 minus 9/10 x. And this, by the way, is x. So either way, you can find this by setting z equals 0 and solving for y. That's how you can get that middle limit. Or you can do it geometrically by looking at the y-intercept and the slope, making sure that you understand that the slope is negative. So this is going to be 18 minus 9 over 10x. Okay, I'm kind of running out of space here. So let me just move this a little bit here. 18 minus 9/10 x. And the final thing that we need to do, which is just, by the way, integrating 1, dz, dy, dx, is we're going to need to set up the z limits. So, okay, so we set this up. So this is 0 to 20. This is 0 to that line, which is, again, obtained by making z equals 0 and solving for y. And then finally, the z limits. So the z limits are bottom surface to top surface. But the bottom surface here is the xy plane, which has the formula z equals 0. And then the top surface is the tetrahedron, but we do have to express it in terms of z. So because it's z equals something, we need the surface in that format. So if I put 12z equals 180 minus 9x minus 10y, dividing everything by 12, will give you the inside limit. So everything here was gonna be divided by 12. So this looks like that's 3/4 x minus 5/6 y.